Lesson 2, Meaning of Mathematics. Now, on some level, we all know what math means. But the point of looking at the meaning of mathematics is to consider that sometimes the way that we teach math might close off entire categories. For example, if you were to ask a child, third grader, fifth grader, what math is, they would likely describe something to do with procedures, right? They might say adding and subtracting. Part of the problem with the way that math has been taught traditionally is that the math in the classroom is too different from the way math is used in the real world, the way that it's used in higher math. And by connecting the meaning of math, by connecting what we do in the classroom to how math can be seen all around us, it makes it a lot more exciting and engaging, and it makes it much more accessible, right? Some kids feel like math is this foreign language that has nothing to do with the real world. It's just something we do in school. So looking at the meaning of mathematics will help break down that barrier and really get children to see that math is everywhere around them, right? So here are two definitions: the study of measurement, properties, and relationships of quantities and sets using numbers and symbols. So that's a very broad definition. It gets to the heart that we're using it, right? Measurement, this is something we use to measure. Also, properties, numbers have a property in and of themselves, right? This abstraction where we can work with numbers that we might not see in the real world, but that we could imagine. And also we're relating numbers to each other, right? So if I multiply 4 times 5, there's some relationship of 4 to 20, which is that it's 5 times larger. Quantities, sets, these are grouping numbers. And then the idea that we use symbols to represent numbers, so reinforcing the idea that math is an abstraction. Another definition, it talks about science, and math is often referred to as the language of science. And here we're looking at structure, order. How do we take big quantities or really small quantities and organize them in a way that we can make sense of them? And what I love about this too is that we talk about evolving, right? We started with these elemental practices of counting and measuring, right? Early humans used hash marks or symbols or counted on their fingers. And when we can create for children that image of math starting with these really basic things, and we develop more advanced processes as a way to make it easier, then math seems like a solution as opposed to math feeling like a problem. Here's a definition that's a little bit more poetic, and here we see the language of science. It's pure language. It's precise, right? The thing that a lot of mathematicians love about math is the purity of it, the way that you can look around you and you can find it everywhere, from the height of the wall in front of you to the number of shelves on the bookshelf next to you, to the time it takes you to walk to the corner, right? It's everywhere, and we can really process anything around us in a mathematical way. So here's a breakdown of what math looks like in a traditional classroom and what the goal of Common Core math. And I use the term Common Core broadly because Common Core is a pretty specific policy, but a lot of states have developed their own systems, but nowadays almost everything is really Common Core inspired. Even states that have decided we're going away, we're not using Common Core, it's still kind of Common Core with a few tweaks. So I'm just going to use this as a general term for the newer approach to math. Even if it's not exactly Common Core, it probably looks like it. Traditional math puts a priority on arithmetic, performing mathematical operations. Can you add, subtract, multiply, and divide? With Common Core, we want to balance that with concepts and applications. Don't just multiply. Think about what it means. Think about how you could use this in the real world. In traditional math, there's an emphasis on memorization, right? You need to know your times tables. You need to memorize rules. What is the commutative property? What is distributive? In Common Core, we're going to include algebraic thinking. So again, instead of just memorizing your times tables, look for patterns. How can we generalize? If you understand what's 4 times 6, can you use that to get you to 5 times 6? And the same thing with algorithms. Why does the division algorithm work? Why is multiplication commutative? In traditional math, we look at the meaning of numbers. What does 88 mean? What does 0.08 mean? What does the subtraction sign mean? What does the addition sign mean? And in Common Core math, not that we get away from those things, those are really important, but we also think that math is a language. You have mathematical ideas and you can represent them in multiple ways. And finally, I've shown how visual models can support both traditional and Common Core math. One is not more important than the other. You can't just do mathematical concepts and not be able to multiply, right? At some point you need to use algorithms or use some of these traditional systems to solve mathematical problems. You don't tend to see visual models. I didn't, right? When I was in school, we didn't see visual models. But just because they've come in with Common Core doesn't mean they only support concepts and application, because, as we'll see in a bit, they also develop numeracy. They help us understand what numbers mean and to become more fluent with our operations.